In figure 2.9 earlier, we looked at an example where we had an ink stain that was growing, and we had a function A equals f of r, where the area of the circle that was formed was a function of the radius length, and we had some units on there. A was the area in square centimeters, and r was the radius length in centimeters. If we wanted to know what are the units of the derivative of f prime of r, we could use the dy dx, or the change in output, the change in area, over the change in input, the change in radius. So this is a small change in area divided by a small change in the radius length. The units for that, the units of dA over dr, or the units of f prime of r, would be centimeters squared in the numerator and centimeters in the denominator, or square centimeters per centimeter. I'm going to resist the urge. I'm going to urge you to resist the urge to cancel a centimeters here and just say centimeters, and here's why. If we wanted to give an interpretation to a statement that said something like f prime of 3 equals 9.42, what would that mean? And so a couple of ways that we could say that. Well, let's first figure out what the 3 means. The 3 is an input, and so the 3 is talking about 3 centimeter radius. And that 9.42, that's talking about 9.42 square centimeters per centimeter. So here's what that means. Here's some ways to interpret that. The first is when the radius is 3 centimeters, the area is increasing at a rate of 9.42 square centimeters per 1 centimeter increase in radius length. That's one way to say that. I don't want to reduce this to just centimeters because the area is not increasing at 9.42 centimeters. 9.42 centimeters is not a unit of area. Another way to say this would be something like when the radius is 3 centimeters, the area will increase approximately 9.42 square centimeters if the radius was increased by 1 centimeter. And this goes back to this idea of 9.42 square centimeters per centimeter being the same as 9.42 square centimeters over 1 centimeter. So these are some reasons why we would want to not cancel the units, but leave it as square centimeters per centimeter, because we're talking about a change in area in relation to the change in radius length. With technology, there are some different ways to do this. We've already seen with GeoGebra how we could take and graph the derivative. So for Desmos, I've got Desmos here, and we can, let's see, type in the equation that I'm looking for. F of x is equal to x squared minus 2 to the x power. We looked at that function already. if I want to graph the derivative, there's a couple of ways to do it. One way is to click the Functions button, and I get a whole slew of functions. Click on Miscellaneous, MISC tab, and then under on the right side, almost all the way at the bottom, there's this fraction-looking thing that has d over dx, and that's one way to get Desmos to do the derivative. We'd say d over dx and then f parentheses x, and that gives you the derivative of the function f of x. Another way to do that is to, and this is probably much simpler, is to just type f prime of x. So how do I get, that's f comma, shift f prime of x. And that gives me, in green, the same function. If I delete the one with d over dx, I notice I get the same function there. So that's another way to do that.